Hi, this is video number 4 of Basics of Trigonometry. We're going to look at some special values of sine and cosine. But first, let's have a quick review of the definitions. So for every number of theta, we can match a point on a unit circle. This is theta, we match this point N, and it has some coordinates x and y. The sine of theta is defined as the y-coordinate. This is sine theta. And the cosine of theta is defined as the x-coordinate. So this is cosine theta. Let's see in this GeoGebra file how cosine and sine are changing. Here we can see the unit circle with alpha equals 0 degrees, and sine and cosine are 0 and 1, that's the coordinates of the point. When we change alpha, the matching point is changing, and sine and cosine are still the y and the x coordinates. When we go from 0 to 90 degrees, notice that sine goes up from 0 to 1, and cosine, the green line, goes down from 1 to 0. When we continue after 90 degrees, sine goes down to 0 and cosine goes to -1 until 180. And then both of them are negative. Cosine goes back to 0 and sine goes down to -1. At any point, look at this one for example, the matching point is here with its coordinates. Sine is the y coordinate and cosine is the x coordinate. Continue to 270 and back to the starting point where cosine goes back to 1 and sine goes back to 0. And then we can continue for another circle and another circle to get sine and cosine for every value. Let's summarize the minimum and maximum values of sine and cosine. As we saw in the unit circle, since the radius is 1, the minimum value must be -1 and the maximum value must be 1, both for cosine and sine. We will now go over some special values of sine and cosine. This is for 45, 30, and 60 degrees, or pi over 4, pi over 6, and pi over 3 in radians. It can be proven that these are the values. I'm not going to prove it here, I will only give a hint later here in this file, and at the end of the file you will find the full proof. These are the values that it is really recommended and will be really useful for you to know by heart. Let's go over them. Sine and cosine of 45 degrees or pi over 4 radians is √2/2. This is the exact value. It is equal to 0.7071. This is rounded. The exact value is √2/2. For 30 degrees, sine is 1/2 exactly, and cosine 30 degrees is √3/2. And for 60 degrees, sine 60 degrees is √3/2, and cosine 60 degrees is exactly 1/2. The same here is in radians. Let's summarize all these values that you need to know by heart. Okay, this is almost everything you have to know for the quiz. You have to know how to convert these values from radians to degrees, and from degrees to radians, and you have to know the sine and cosine of each of them. Next, you have some hints here to the proof of the sine and cosine of the values we saw before. Try and prove it using these hints or in any other way. And we will go on to the sine and cosine of values in the other parts of the unit circle. That's the second, third, and fourth quadrants. We'll start with sine. Say we're given some angle alpha between 0 and pi over 2, say this one, and we're given the sine of this alpha, which is this. This is the y coordinate. And this is sine alpha. We're interested in the sine of pi minus alpha, pi plus alpha, and minus alpha. Notice in this drawing that this is also alpha. So, given that this is pi, 180 degrees, so this point match pi minus alpha. And this point, if this is also alpha, this point match pi plus alpha. And given that this is also alpha, this point match negative alpha. And we are interested in the sine of these values. These are the sines. The y coordinates. It is very easy to prove that these four sides are the same because the four triangles here are identical. The difference is only in the sine. This is sine of pi minus alpha, and we can see that this is just the same as sine alpha. They have the same y coordinate. For pi plus alpha, we can see that the y coordinate is the same in value, only it's negative. Sine pi plus alpha is just minus of sine alpha. And the same goes for minus alpha. This is sine of minus alpha. It is equal to sine alpha, only a negative. Okay, this is sine alpha, and this is minus sine alpha. So here's the summary of the rules we found in radians and in degrees, and this will be very useful in questions. Let's do the same for cosine in the other three quadrants. You can see here that cosine alpha and cosine of minus alpha are the same, positive, and for pi minus alpha and pi plus alpha, cosine is negative and equals to minus of cosine alpha. So this is a summary for the cosine rules and summary for sine and cosine together. Let's see some examples that use these rules. This is a solved example where we're given the sine of 10 degrees and use that to find sine of 170, which is 180 minus 10, the sine of 190, which is 180 plus 10, and the sine of minus 10. This is an example of finding cosine values. Using the value of cosine 40, we can find another 3 values in the 3 other quadrants. And let's solve this example that involves exact values that we already know. Here we're given the sine and cosine of pi over 6. This is 1/2 and root 3 over 2, which we already know. And we will find the sine and cosine of 3 other values using these given values. I remind you that pi over 6 is 30 degrees. So 5 pi over 6 is just pi minus pi over 6. We can write this as pi minus pi over 6, and this is cosine of pi minus pi over 6. We know that the sine is just the same as sine pi over 6, and cosine is the negative of cosine pi over 6. So this is 1/2, and this is minus root 3 over 2. 7 pi over 6 is just pi plus pi over 6. Refer to pi as 6 pi over 6, so we add 1. And this is cosine of pi plus pi over 6. We know by the rules that both of them are negative. So this is minus sine pi over 6, which is minus 1/2, and this one is minus cosine pi over 6, which is minus root 3 over 2. For minus pi over 6, we know that this is minus of the sine, minus 1/2, and this is just the same as the cosine. This is root 3 over 2. On the circle, we can see that given the sine and cosine of one value in the first quadrant, pi over 6 or 30 degrees, we can find the sine and cosine of 3 other values in the 3 other quadrants. This is 5 pi over 6, pi minus and pi plus is 7 pi over 6, and minus pi over 6. Notice that they have the same sine and cosine except for plus and minus. Here's the drawing that shows all the exact values of sine and cosine that you need to know. You have here the multiples of 30 degrees and 45 degrees, or pi over 6 and pi over 4, and near any point you can see the two coordinates, x and y, which are actually the cosine and the sine. Notice that we can divide the values into groups of 4. 30 degrees or pi over 6 goes together with 150, with 210, and with 330, which is actually minus 30. These 4 values have the same x and y, except for the direction. They are all root 3 over 2 and 1/2. Root 3 over 2 and 1/2, except for plus and minus. Another group is the 45 or pi over 4 with 3 pi over 4, 5 pi over 4, and 7 pi over 4, which is actually minus pi over 4. They are all root 2 over 2, both sine and cosine, except for the direction. And the third group is of 60 degrees and 120 degrees, 240, and minus 60. They too have the same sine and cosine except for the direction. They are all 1/2 root 3 over 2, except for plus and minus. first quadrant, sine and cosine are positive. In the second quadrant, sine is positive, cosine is negative, and so on in the other two. So this is a way to remember and to understand the values of sine and cosine. In the quiz, I will be asking, for example, what is cosine of 7 pi over 6? What is sine of pi over 4? And so on. You have a practice file with this type of questions and others, and I hope you will go over it and be ready to the quiz we'll have on our first meeting on Sunday, and then we can go on with trigonometry. So thank you for listening, and I hope to see you soon.